So let's talk about the paper structure. What we'll do is, there's usually pretty well-defined sections that you're going to want to develop. It's really good to know what those sections should include. So we'll just kind of go through in the order that typically appear in the paper. The first thing would be the abstract. Can't stress enough that the abstract is not an introduction to your paper. What the abstract is should be a really succinct, like, bottom line. This is what my paper is intending to do. This is its contribution. This is the methodology that I'm using, and then these are the results. Right. So the abstract in no way should be like left as a teaser for the research. The abstract should tell the reader, this is my conclusion. This is what I found in this paper. Because you have to think of the abstract as really the only thing that a lot of people are ever going to read. I mean, you guys know how it is. You, at some point, are going to be reading through a lot of papers, doing your lit review, and you rely quite a bit on the description in the abstract to summarize the paper accurately. So if you give your abstract just a second thought as the very last thing you do, you're probably going to not describe the work that you've done very accurately. And then when people are characterizing the work, they aren't going to be able to get a really good sense of what you've done. So this should be, typically there's word limits, but a couple paragraphs covering the main points that I have here. The introduction, this I think is where a lot of people get hung up when they're starting to write a paper. Like, they sit down and they think, okay, introduction, and they get this like mind blanked look. And so you really don't want to start with the introduction. You want to leave that for the last thing. And the reason why is you as engineers are going to be going through doing the methodology, getting the results. That's kind of what comes naturally. So do that first, right? Get that set, and then you'll be at a point where you say, here's a conclusion. Here's the thing I'm trying to describe. What is a typical reader of this paper in this field of study going to know, and what are they not going to know? If they're not going to know something, I need to say that up front in my introduction. So if you think of, like, I don't know what a good example would be. We could take, the work that Sammy and Ty are doing again, for example. Like, a typical person who's familiar with concentrating solar, they're going to know what a heliostat is, right? So you don't need to go and describe in detail whatever heliostat looks like. They're going to know what Monte Carlo ray tracing is. You don't have to describe that. You also don't probably need to start off by saying, well, climate change is a problem and energy sources are this and that. Like, that's been done, right? So you want to kind of jump in at a starting off point where the typical reader is going to kind of know, yes, ESP is important. Here's some common modeling tools. But you would say, yeah, here's specific methodologies in this area that I'm going to be using. Here's why I'm using this methodology. Here's why I've gotten to the point where I realize that this is important. So I guess I have these three things, right? Specific factors or challenges that make the work necessary, additional information that might be needed, and then any work that's been done previously by you that leads to the current work. So this is not a literature review. This is stuff that we've done before that we just need to recap to get everybody up to speed. So coming out of the introduction and background section, the reader should be at a point where they've either been reminded of the important things in this field or been introduced to nuances that they maybe haven't appreciated that are going to then help them understand anything you're going to say that comes after that. Then you get to the related work section. This is, I think, something you guys are probably a little bit more comfortable with. The main goal of the related work is to draw a distinction between what others have done and what you are doing. So there's kind of two flavors here. One is somebody's doing work that on the surface or in any way actually does overlap with what you're doing. And in that situation, you need to be very clear about specifically how your work is different and or how your work is valuable compared to what they've done. Because if you just go and try to publish something that's already been done in its same form, then the journal's going to say, like, why would I publish this? I'm not going to waste my resources and my editors and all that republishing something that's already been published. It's just not going to get any reads. So, right, you don't want to do that. You want to just find a way, and that could be, for example, that the previous people who have done it have made a simplification. They've made an assumption. You don't make that assumption. We consider it in detail, and that changes the results in some way. It could also be, it's rare or more rare, but it could be that you think that prior work is actually incorrect, that there was some fundamental error that was made that led to an incorrect conclusion. That we want to be careful with, because you're basically calling into question the reputation and careers of other people, and so you need to be sure about that. But it's possible. And then the third thing is that there's been work that's been done that is foundational, that you're going to build on, but doesn't really overlap, right? But it's really important to what you've done. It's led up to what you've done. You just need to make a record of it and say how you're building on it. So that's kind of the related work. I think there's maybe a lot more to say there, but we can leave it at that. The only thing I'll say is it is natural for some people to try to go in and find flaws in everything that everybody else has done. Say, like, keep in mind that when you're writing in this field, in the field that you're in, the number of people who are in that field is relatively small. Right? By definition, you are at the forefront of that field. The other people who have written that you're citing are likely to read what you've written. So if you go throw somebody under the bus, keep in mind that you might hear from them directly, right? And it's not that you shouldn't do that, but just keep it objective, right? Be as fair as you can. If somebody's made a great contribution in that area, say it, right? This contribution is really important. We aren't challenging what they're doing here. Instead we're building in this area, whatever it is. Okay, so then you kind of get through this introductory stuff, the background material, and then you come to really the heart of the paper, and that's the methodology. The methodology is probably the longest section, depending on, most of what we're doing in this group is the methodology is going to be most of the paper. In the methodology, what you're doing is describing how somebody else coming along who's an expert in the field could replicate what you've done. So think of it like it's a recipe, it's a set of instructions, but not quite as dry as that. You shouldn't be just listing out step by step what you do. It should be a pretty well thought out narrative of why you're making these assumptions, what the assumptions are, what the model looks like, how the equations relate to each other, and all that. So you're going through that full discussion for the methodology. Yeah, focus on general steps, providing specifics where necessary to clarify. And then instead of saying, like, if you're using transist for your modeling, you don't need to go in and describe every transist type. You need to say cite the papers that first presented them, and then we're taking this existing model and modifying it in XYZ way. So where you depart from common practice or you make a novel connection or contribution, that's really where you're focusing your description. Okay. Let me stop. You guys have any questions? Okay. Okay, so methodology, here in the methodology, you're really not presenting anything to do with outcomes or results. I mean, you can have outcomes in the sense that you've established a methodology, but you are not like saying, and here's what we found. The results and discussion would be that, where you go through, and if you've got data, you've got model output, you've got plots from stuff that you're doing, that's where you're presenting the result that's there in a very factual way, in a very at an arm's length way. So you're just basically describing what it is that you found, or what it is that you observed, and then saving any of the interpretation or, why is this important? That comes later, right? The results and discussion, that is just, what is the result? How do I interpret what that result, what the data is saying, in a very strict sense? And then later, in the conclusions and future work, that's where you make the connection. So you say, I've got this plot 1 and I've got plot 2. And if you make a connection between those two, or you say, under certain circumstances, this is true, then you're making a bigger implication for the field or something like that, right? You're combining stuff together to tell kind of a story. So in a scientific sense, what you're doing is keeping separate the strict data, or the kind of the raw part of it, the just observational part of it. You're keeping that separate from your own interpretation and your own human narrative that goes with it. So sort of factual stuff versus interpretive stuff. As much as possible, the conclusions, and then the future work would come in that interpretive section. For future work, I guess things to say there. You don't feel like you have to tell everybody what they should do next that you're going to do, right? Because then you're undercutting your own ability to do unique work. What future work should really focus on is if you have limitations in the current data, or contradictions that you couldn't resolve, or you had a null result or negative result that you wanted to explore further, that came up in the results. That's where you would say, okay, here's where we would need to go to reinforce this work. You don't want to say, and here's where our lab is going to propose next, right? Because that screws your advisor over a little bit. So yeah, so that's I guess the main parts of the paper structure. Yeah, lots to talk through there, but I think that at least gives you a clear sense of what's going on. Oh, last thing, bibliography, right? Pretty obvious. I think some things to say about the references are that some people will say you should never cite yourself. I don't think that's true. I think if you don't cite yourself, you run the risk of repeating yourself over and over. So if you've done some prior work that's led up to this current work, you should be citing that prior work, and that's a self-citation. That's fair. You can do that. One thing that you might run into, depending on the journal, is you might send your manuscript in, get some comments back, and the editor says, are you sure that you've checked over the current journal for related publications, right? Sort of implying you missed something. What they're actually trying to do is increase the impact factor of the journal by getting more citations. So just be aware that can happen. So probably what you want to do is look through existing articles in that journal, just to pick some out that are related, cite them. That's something that the journals often like to see. Not at the expense of doing anything that compromises the work, but just double check to make sure that there's not something already been published in the journal that we could cite.